7, 8, and 9 are classifying systems of linear equations from graphs. We're going to do systems of equations that are two lines. And if I have two lines, there are three different ways I can draw two lines. One way is just to have one line that intersects with another line. If one line intersects with another line, it's called consistent because it has an answer. Independent means it has one answer. The one answer is the point wherever they cross. So these will have a unique solution, whatever the point that they cross in is what your answer is. Another way to have two lines is if you have two lines that are exactly parallel to each other. My lines weren't very parallel. If my lines are parallel, they're never going to touch. So the two lines are never going to have anything in common. Those are called inconsistent and will have no solution because they're not going to have anything in common. Third way I could have two lines is if I have one line and my other line happens to be exactly on top of that line. Whoa, my line went crazy. If my one line is exactly on top of my other line, it is called, if my pen would write, I'm going to close my thing. If my one line is right on top of my other line, hopefully you had those other two written down, it is called consistent dependent. And what happens is every single point on the line is a solution to both of my equations because they're really the exact same line. So they're going to say that there's infinitely many solutions. So those were the three ways that you could have your lines. Either they intersect in a point, they're consistent, independent, they're parallel, they're inconsistent, or they're really the exact same line, one on top of the other, consistent, dependent. So on each of these, you're going to have one of each of those, and you're just going to pick them out. So on this first one here, I have two lines that are parallel. If my two lines are parallel, they are inconsistent. They're going to have no solution because my two lines are not going to touch each other. On my second one here, notice I have one line intersecting with the other line. If one line intersects with the other one, they're called consistent independent. Independent meaning one. The solution is the point where those two lines cross. So at 1, 3 is where they cross. You're going to have a unique solution, and you're going to put in that ordered pair, 1, 3 being the solution to my system of equations. So that if I put 1 in for x, I get 3 for y. If I put 1 in for x here, I also get 3 for y. Works in both of my equations. The third one, that's the one where it says line 1 and line 2. I have two separate equations, but if I rearrange my equations, they'd be the exact same thing. Those are the ones that they call consistent dependent. My other phantom writing shows up. Consistent dependent, they're going to have infinitely many solutions because every single point on line 1 is going to be on line 2 since they're the same line. So 8 and 9 going to be the same kind of things. This first one here are the ones where they touch in a point. If they touch in one point, you get consistent independent. Perhaps you get consistent independent. There it goes. You get consistent. Whoa, now my board moved. They touch in a point, we get consistent independent, and the point where they intersect is your solution, so these ones intersect at 0, 3. It doesn't want me to write. There we go. So consistent, independent, unique solution, 0, 3. The next ones, we have two lines that are parallel. If we have two lines that are parallel, those are the ones that are inconsistent. There, it wrote there, inconsistent, and will have no solution. So if my lines are parallel, inconsistent, no solution. The third one on this one. Get to the right one, my board wants to hop around. That's the one where I have line 1 right on top of line 2. If line 1 is on top of line 2, they're actually the same line. Those are consistent, dependent, and have infinitely many solutions. One more of those. Go ahead and try to answer number 9 while I'm trying to get the board to write. So on number 9, we have one line and our other line. They intersect in a point. Since they intersect in a point, they are called consistent independent. The point where they cross is your solution. They cross at 3, -1. Second one on number 9. That's the one where you have one line looks like it's right on top of the other line. If I have one line right on top of the other line, that means that they're actually the same line. Those ones are consistent, dependent, and have infinitely many solutions because every point on line 1 is also on line 2. And the last one of these kind is the one here where we have those two lines that are parallel to each other. If we have two lines that are parallel to each other, those are the ones that are inconsistent. They might want to be inconsistent. Inconsistent, there it wrote, and have no solution. Since those two lines are not going to touch each other, my two equations won't have anything in common.